All right, everyone. Welcome to our webinar with the very impressive title, How to Leverage Azure OpenAI on Internal Documents and Beyond. In this webinar, we're going to talk about some different topics. So going from generative AI to Azure OpenAI, and of course also how to leverage those technologies on your own documents and how you can use them to chat with your own data. So without further ado, who am I? I'm Joran Vergouwen. So I work at element61, obviously, as an analytics architect. I have 3 years of work experience, and if someone of you already attended a meetup by the Generative AI Belgium meetup group, you might already know me because I'm a co-host of that meetup group. And I'm here joined today by Peter and Louis. So Peter is also from element61, and he is a partner actually, so at Data Science and Analytics. He has already more than 10 years of experience in the data science field. And we are also joined by Louis. So Louis, who is Louis? Louis is actually a Microsoft MVP in artificial intelligence and machine learning. He has also more than 10 years of experience in the field, and he is a machine learning engineer here at element61. All right. So what is the goal of today? The goal of today is to give you guys an insight on, first of all, generative AI. What is generative AI or what is it not? And also how you can leverage it to chat with your own data. We're going to keep it quite high level here in this webinar, but here and there we're going to make some technical detours. So please fasten your seatbelts and get ready for the ride. So how we are going to tackle our webinar actually is we're going to look at generative AI or look at the project, so to speak, from two different angles. So the first angle will be the NLP angle, so the very technical angle. And we're going to see, okay, how did NLP actually evolve into something that is capable of doing human-like chat behavior? And then in the second angle, we're going to look at your own data, because obviously we don't just want to chat with a random bot. We want to be able to chat with our own data. So we're going to look at, okay, what do we need to do to prepare our data to be able to chat with it? Then we're going to bring those two angles together, basically, into one proof of concept, if you will, one demo that will allow us to chat on our own data. We're going to need some additional components like a framework to code it all in, which is going to be LangChain. And we also obviously want to have a nice front end for our end users, which will be Streamlit and Teams. But more of that, of course, during the webinar. And obviously, we're going to end up that section with a demo of something that we built. Then furthermore, we have that demo, but that's going to be a very basic chatbot, if you will, that has basic functionalities to chat with your data. But there's always ways to improve the experience, ways to improve the output and the relevance of the answers that are being given. So we're going to talk a bit about how we can do those things. So we're going to talk about retraining or training your LLM or foundation model, about prompt engineering and fine-tuning, and about a concept called semantic search. Once we've wrapped up all of those topics, we're going to go a bit more into the challenges and limitations of generative AI, the future of generative AI, and we're going to end up with a small conclusion and a Q&A session. All right. Before we jump in, maybe a small thing about practicalities. If you have questions, feel free to either drop them in the chat or even better in the Q&A section of this Teams meeting. Both you can find on top of the Teams menu. And for longer questions, you can also just wait for the end and just ask your question like that if it's too long to type it in. We're also recording this webinar, so there's no need to take screenshots or anything like it. Just make sure that you're with us the entire time, and you can get the webinar at your disposal right after the call. And then last but not least, when you're experiencing issues, for example, there's no sound or it's hard to get into the call, please try to just leave and re-enter the webinar. And if the issue would persist, you can obviously let us know. All right, without further ado, I'll leave the word to you, Peter, for an intro into element61.
Yeah, thank you, Joran. First of all, welcome everyone in the call. It's a pleasure to see how many enthusiastic people we have here. Before we go into the actual meat on the bone in this webinar, I want to give a quick introduction on who element61 is. I think most of you already know us, but some people, it's the first time that we have an encounter with you. So who are we as a company? We are a group of consultants. We'll be 120 people as of next Monday. We have a bunch of people joining us from school. So 120 people, and we are active in 3 big domains. The first one, bottom right, is everything related to business intelligence, where we help organizations centralize data coming from different data sources. In the past, it was quite straightforward. We were working with very structured data coming from ERP systems, CRM systems, etc. We're now moving more towards a modern way of looking at data. So we're ingesting as well APIs, real-time sources, unstructured sources such as images, videos, etc., into what we call a modern data platform. On the top right, you see everything related to the finance office. So we help the CFO in leveraging all the data that is available in the organizations to manage their finance practice. So everything related to planning, budgeting, forecasting from a financial aspect is something that we help with. ESG reporting is something that has popping up in the last few months as well, which is something we have experience in. And then lastly, the data science and analysis team on the top left is the team where I'm responsible for, where this webinar in a way resides in as well. What we do there is we want to help organizations get true value and true business value out of their data. So we think beyond the reports, but we think what more can we now do to optimize business processes. And as you know, artificial intelligence plays a crucial or can play a crucial role in that. We always try to help from a business point of view. So we think what is now the business process and how can we now improve this business process. And this can range from manufacturing and operations to customer experience, to sales, to supply chain, finance as well. Typically quite a traditional playing field, but there's opportunities there as well. And then last but not least, about 8 months ago, generative AI popped into the world and is giving us tremendous benefits in optimizing business processes. So what you see here in this webinar is all around generative AI, OpenAI on Azure. But of course, this is only part of what we do. We can do much more, as you can see here on the slides. So this for a very brief introduction. I'll now give the word back to Joran, who will guide you through the webinar. During the webinar, I will ask some provoking questions towards Joran if I think it would be relevant. So we'll try to kind of keep a dialogue ongoing here. And if you have any questions on the in the chat, I will ask them straight away, or we will have the Q&A at the end of the session. So Joran, the floor is yours.
Right. Okay. Thank you, Peter. So first of all, what is generative AI, right? Let's zoom out a bit before we go and dive deep into the use cases and everything in our demo. Let's first set the stage and explain you guys, for those who are still a bit on the fence or who don't know yet what generative AI is, what it actually is. Because the way I tend to look at it mostly is there's 3 kinds of people. There's first of all, there's people who don't know what generative AI is. Then secondly, there's people who know what generative AI is. And then thirdly, there's people who think they know what generative AI is. So to be on the same page from the start, let's give a very small introduction on what we understand is generative AI. So Actually, you have three flavors of generative AI, of three types of generative AI, if you will. And the first one is the generation. Of course, it's generative AI. So we are going to generate stuff. And what is generation? So generation is basically based on a prompt or on a piece of text or anything. A generation model can, or generative AI can create something new that didn't exist before. So what you see on the screen here is actually from Midjourney, an example from Midjourney, where I wrote just a simple prompt of, okay, make me a picture of a landscape with a man who is standing in the sea with some beautiful clouds. And within a couple of minutes, this generative AI model is able to create those pictures for me. So that's the generation part. Secondly, there's also a summarization part. So what is summarization? I think ChatGPT can do more than only summarization, but it's very easy to explain summarization through ChatGPT. What it can do is, for example, if you have an article in a newspaper and you don't really have time to read it, but you want to know the main points of it, you can just drop it into ChatGPT, ask it like, okay, give me explain me this article in 5 bullet points or summarize it in 5 bullet points. And the generative AI model, which is GPT 3.5 Turbo, will be able to summarize that for you. And then thirdly, there's also transformation. So let's say that you already have an image or you already have a piece of text, but you want to see it modified. For example, let's say that the first one, the rhyme about element61, we're not really happy with the rhyme. So we say, okay, let's maybe transform it into a new one. And we can easily ask that to a generative AI model. Or to another model, or once again in Midjourney, for example, we could say, okay, we really like pictures of, or we want to use a picture of a samurai guy who is standing in front of a temple, but we don't like this particular one. Can you make some variations about it? So those are all things that generative AI can do for us. Of course, when you combine these three types or three different ways of looking at generative AI, you can come up with like an endless number of use cases for generative AI. I'm not going to list them all, but one interesting one that I always like to highlight is it's a bit more on the bottom, which is like the age filters. For example, what Facebook was able to do, because a lot of people used to tag people over the years, and what Facebook was able to do was create a generative AI model that is able to predict how you will look like 10 years from now, or 20 years from now, or 30 years from now. And that's all because they had this labeled data. They created a generative AI model, and now they are able to create those age filters, for example. There's also other use cases on this list. For the sake of time, I'm not going to go into each and every one of them, but it's just to give you a flavor. But what we noticed, though, is that in a business context, the text part is often really interesting, because there are a lot of often there are a lot of documents that need to be consulted or need to be searched through, and so generative AI, because of the summarization and generation components that it has, is really good at dealing with this text and giving us something that we can actually use in a business context. So what we're going to do is we're going to focus for the rest of this presentation on the text pillar of generative AI and explaining how this could work for your company. So I promised you guys in the beginning when I said, okay, these are the goals for today, that we were going to look at it from two different angles. So one angle, the first angle that I mentioned was, okay, how did we come to getting those models that are capable of having human-like interactions? How did it evolve in such a way that we can now chat with a bot and it seems like we're chatting with another person? Well, to understand that, first we have to go back in time a bit and talk about NLP, which is where it all started. For those who don't know what NLP is short for natural language processing, and it actually sits on the frontier between computer science, natural language and AI. So it's actually the intersection of those three. So what it is capable of doing is it's capable of understanding, interpreting, and generating human language, which is obviously what we want to do. And some applications of NLP are actually wider than only the chatbot that we're talking about. So, for example, one application could be text classification. Let's say that you're a lawyer and you have a lot of documents that you need to have scanned, and you want to know, for example, which of this document is which kind of legal document. Then you could use a text classification algorithm which would classify those documents for you. Another one would be, for example, email filters. Let's say that you want to automatically know which email is spam or which email is from which client and so on and so forth. You could write an email classification algorithm that would classify those emails. Other use cases include language translation, which is rather obvious, sentiment analysis, and to see, for example, what is the sentiment of a comment or of an email and so on, and predictive text, which is what we're going to jump in right now. Because if you look at predictive text, what we want to do is we want to do more, or we want to do something specific, right? We want to be able to talk with a bot, not just classify stuff and so on. We want to be able to talk with our data. And the component that comes in here actually is called an LLM, which is short for a large language model. I'm quite sure that by now most of you already have heard of an LLM, but what is it actually? So what is an LLM? It's basically a very large model, which is why it's called large language model, which is trained to predict the next word. And so what it does is it basically takes an input, for example, a question you have. And based on that question, it's each time going to predict the most likely next word until the entire answer to your question is answered. So worth noticing here is that these LLMs only occupy a small part of the bigger NLP field. And so how are they trained? I already said, okay, these are typically trained on vast amounts of text data. What usually happens is the organizations who will train such LLMs will basically scrape all or almost all data from the internet and use all those texts to basically train their large language model. So this way the model will learn the grammar, the context, and various writing styles, and will be able to respond in a human-like behavior. And what is interesting is that this, of course, allows them to create coherent answers to your questions or your prompts. And also we can use them now to engage in conversations, to answer questions, and to provide explanations. And of course, we can integrate them this way in chatbots, or we can use them to write code, translate languages for us, and many more. So by now you might be wondering, okay, now I understand what NLP is, and an LLM is indeed part of NLP, and these are those large models that we can use for multiple different use cases. But how many of those LLMs are out there, right? So first of all, it's worth noticing that basically every big tech company noticed that LLMs were very big in the NLP space. So you can see that the majority of them have a model for their own. So for example, Microsoft partnered with OpenAI to create the famous GPT. Facebook also has its own model, which is called Llama. Google also has one which is called Bard, and even Apple, not on this slide, has an internal large language model which they already use, but they don't know what to do with it. Another thing that you can see is that there's a big difference between some companies or some organizations putting those models basically for everyone to see, which is then an open source model, while other companies typically want to have the IP, if you want, for themselves, which is then a proprietary model. So GPT, for example, and BART are two models that Google and Microsoft keep from themselves, while Llama is an open source model from Facebook, which everyone can use. And then you might wonder, okay, if there are also these open source models, how can I find them? Where do I find these models? And there's actually a platform which the data science community likes to use, which is called Hugging Face. And Hugging Face is basically one big platform and community where you can go and search for open source models to use for your projects. They don't only have large language models like the ones we're talking about, but there's also different models on there. And to give you a flavor of how many of those text generation models are on there, it's about 22,000, but keep in mind that those are not necessarily all LLMs.
Maybe a question on that. So you mentioned that LLMs are trained on, let's say, the internet.
Mm-hmm.
What is then the fundamental, or is there then a fundamental difference between, for example, GPT, Llama, and BART, since they're in a way trained on exactly the same data?
That's a very good question indeed. So the data they're trained on is mostly the same, and actually they're also trained nowadays on even video and other data sources. So in that sense, it's really the same. What they keep hidden though is like the way they train it. Because in essence, what is behind it is a very big deep learning model, is it called? And of course, the way you design that model is up to you. So there will be differences in, for example, how GPT looks like from an architectural standpoint and Llama and BART, but basically in essence, they are very interchangeable in terms of their results.
Yeah. All right. Thanks.
All right. Then another point that is very important to mention is like the ChatGPT and Azure OpenAI craze that has been around for, let's say, not really the last 8 months, but at least the first 6 of those were very very known for the ChatGPT resurgence or insurgence. What is important to know here is that ChatGPT and Azure OpenAI and GPT, they are not the same thing. And to explain you guys what I'm talking about, I have this small slide to make sure that everything is clear. And that's the following. So first of all, we have the LLMs from OpenAI, which are, for example, GPT-3 and GPT-4. And it's important to note that those are just the LLMs. So those are just the models that are made and developed by OpenAI. And then we have ChatGPT. What is ChatGPT? ChatGPT is actually nothing more than GPT 3.5, which is a certain GPT version with some front end built around it in the form of a web application. So what it means is that you can navigate to a website and just have ChatGPT at your fingertips, and in the background is an LLM, which is GPT 3.5, which is doing the heavy lifting for you. Once again, the model was developed by OpenAI, but also the front end is provided by OpenAI. And then we have, as a third component, Azure OpenAI itself. So what is Azure OpenAI? Azure OpenAI is actually the models that were developed by OpenAI, but made accessible by Microsoft. So how you can see that is just a collection of pre-trained LLMs, which are callable through an API, so you can use them in your own applications. It's important to note, though, that these are private models, so it means that your information stays on your own Azure tenant. So if you use any of these models, it's not the case that your data or whatever is going to be shared with Microsoft or OpenAI. All right, and then as the last one, you also have the opportunity to fine-tune those models, but we're going to dive into that a bit later in this webinar. All right, so we've covered the first angle basically, which is how do we go from NLP to these large language models, which allow us to basically chat in a human-like way. But we don't just want to chat in a human-like way. We want to be able to talk about our own data, and we want the algorithm to understand what the data of our company is, and more importantly, or equally importantly, we want to do that in a safe way. So how do we go about that? Let's take a look at our data to do that. So what do we have is, when we look at our data, we see that our data is basically located in a lot of different locations. For example, you might have data on the SharePoint, on the SQL server, on the data lake, and so on. But also in terms of the structure of these locations, there might be a difference. For example, on your SharePoint, it might be in some kind of folder structure, where on your SQL server, it might be organized in databases and tables. And then last but not least, we also have a way, a lot of different file formats in which these documents can come. For example, we might have PDFs, Excel, Word, or even video on our SharePoint. We will have tables and views on our SQL server, and we can have a plethora of data types on our data lake, like Delta tables, CSVs, Parquet, and so on. So what's the first problem here is that we have a lot of different data types, and we want to somehow be able to feed that to our model. So a first step in that is to actually go from these different data types that we have to one data type that we put everything in. You can compare it to, for example, once again, if you're a lawyer and you have a lot of documents, for example, you have a pile of papers on your desk and you have some scanned documents already on your computer, what you want to do is basically scan all your documents that you have on your desk and have somewhere that you store all of the PDFs and everything is in the same format. Basically the same thing we want to do here. So what is a document? A document is basically a piece of text and associated metadata, and it's always the same format. So it's a uniform format, which we call the document format. And how do we create those documents? Once again, think about scanning your PDFs. Basically, our scanner will be our document loader, and we will have different document loaders which we can use for different data types to basically read them in and store them in memory as a document format. So typically those document loaders, they have some kind of load method which you can then use to scan your, or to load in your data. But then there's another problem. So we have our documents and we have put them in one and the same format. But the problem is that they are still in text. So it's still going to be text with metadata. And an LLM, or a computer in general, typically doesn't understand text. A computer wants numbers, right? So what we're going to do here is we're going to use a technique which is called embedding, which is basically going to represent our text in a series of numbers. And what we're going to do is, if we take an example, for example, of the words king and queen and man and woman, what we're going to do is we're going to represent those words in a multi-dimensional space. So we're going to give them coordinates, or we're going to assign a vector to it, if you will. So for example, what we do is we create a vector for king, or a coordinate for king and a coordinate for queen. And they will be in such kind of way that words that have a similar meaning will be very close to each other, while words with a completely different meaning might be further away from each other. And also the relationships between those words can be captured by our embedding. Let's say that here we have king and queen and man and woman. You can see that the distances between king and queen and man and woman are very similar in our embedding. Of course, and for this example, we used a 3D embedding, so 3 dimensions, so we can still visually represent it. But in reality, we will have multiple dimensions, which makes us able to capture even more nuances and more meanings in each and every dimension that we have. So basically, what are the benefits of having these embeddings. It's very efficient because we can store words as a series of numbers instead of the words themselves. We also have enhanced semantics because we are using these dimensions to basically capture the dimensions and the meanings of those words. And we also have improved performance because we have now basically one type that we are going to put all our words in, which is this dimension, which is a very nuanced representation.
Is this then the same way how these models are trained? So I understand that we use the internet, so text from the internet. Creating those embeddings is actually then the training that is happening on those LLMs.
That's a very good question. So the same thing is going to happen when those models are trained. Basically what they are doing is, let's say you have video and text. They're first going to grab those videos and text. They're going to create documents from it. They're going to embed it. And then they're going to use those numbers or those factors of numbers to train the LLM. So we're going to actually mimic that process with our data. That's a very good question.
Yeah. And so that's then the reason why if we chat, we do not need to have the exact word, but more or less a synonym or a word that is similar, because due to the embeddings, the bot understands that it's actually the same thing that we're talking about.
I'm glad that you asked that question because it refers back to what we see on the screen. For example, if you would ask a question about a certain word, let's say a wall, and the embedding or the document doesn't describe it as a wall, but for example as maybe a synonym for a wall, or like or heproc or something like it, then the model will know, okay, these words are actually the same because this is actually a material or stone or whatever, or brick. This is actually a material to make walls, so it will be close to each other. So the algorithm will somehow know, like, okay, these are words that are very similar to what a wall is, so it might be something in this direction. So that's indeed a very good question there.
So it's kind of the word clouds that we use.
Exactly.
That is
exactly, and that's a very good point, because here I have something that actually looks a bit like a word cloud, because this is how, once again in 3D, how you could envision how such an embedding would look like. Once again, it's going to be multiple or more dimensions in reality, but here you have some kind of sticky notes where on every sticky note we have a word. And those words will have a certain place in the n-dimensional space. In this case, once again, 3 dimensions. And so you can see that words with a similar meaning will then be close to each other, and so on and so forth. All right. So a small recap. What we did, once again, we had our files. We stored them in a document format, so they all had the same format. And then we embedded them, basically, so we created vectors with numbers so a computer would understand it. But obviously what we cannot do is we cannot just leave it there. We need to have some kind of storage unit, if you will, where we can have like one big silo, and we put all our vectors and all our documents in there. So that we can later, first of all, we can now store it in one organized space, but also so we can later search them if we want to, for example, query our documents. And that's where a vector store comes in. So what are vector stores? They are basically big stores that allow us to store these high dimensional embedding vectors, and they allow us to not only store it but also perform something which is called vector search. And what is a vector search? We already hinted towards it a little bit. If you have a question about your data, the same thing is going to happen as the mechanism that we just described. So that question is going to be transferred into those vectors, and the vector search, which is the mechanism that will look up similar documents, will then check, okay, which vectors in our store are similar to the vector that that is created from your question. And based on that, it will basically spit out the documents that are most close to your question, because probably in those documents the answer to your question will be present. So that's the vector search mechanism. Of course, you can already see that there's some benefits of using a vector store. First of all, it's very efficient. It's very fast to retrieve similar items from large data sets because we can just look at the distances of those vectors. Furthermore, it's also scalable because we just put it in a n-dimensional space. So looking into an n-dimensional space will always stay the same n-dimensional space. If you put more documents in it, it might maybe lose marginal performance, but we're still talking about the same n-dimensional space. And then thirdly, there's also specialization because we can optimize this vector store to do exactly those two tasks, which is saving or storing our vectors and then searching for similar vectors once someone comes in with a question. So one thing to remember is that those vector stores are basically just specialized storage units for AI, making it easy to work with complex data. And so to make sure that everyone is on the same page, let's recap a bit what we did in this part here. Is we first had our files, which can be any format, for example, PDF, a SQL table, or a Word document. And those ones we're going to load in memory as a document type. So you can see that those are now 3 of the exactly the same document type documents. After that, we're going to actually embed them. So we're going to create vectors from them. And then we're going to store those vectors in our vector store. That's basically the mechanism behind it. And then once someone comes in with a question, we have our question of our query, and we're going to do exactly the same with that query. So we're going to vectorize that query, and it's also going to be a representation of numbers in a vector. And then we're going to basically feed that vector to our vector store, which will search for other vectors which are very close to this question or this embedded question. And then it will say, okay, I found, for example, 3 documents which are very closely linked to this question. So probably your answer to your question is going to lie in those documents. And then, of course, we can translate those documents back to files. So we have our PDF, our SQL table, and our Word document back. So we're back to square one. All right. So now we have basically seen the 2 angles. The first one was NLP and how we can use that to chat with our data by use of those LLMs. And secondly, we looked at, okay, but we don't want to just talk with a random bot. We want to talk about our data and how can we do that. And now is actually the time to bring those 2 together and see how those can work in conjunction. So without further ado, how does it all work? And now I have to make sure. Yeah. So how does it all work? Basically, we're going to go over the same process once again, but we're going to stitch 1 and 2 together and make sure that we can come up with an end solution. So first thing we're going to do, I already explained it very thoroughly in the last section, is we're going to embed our documents. So what we're going to do is we're going to extract the different documents, we're going to vectorize them, and we're going to store them in a vector DB or vector database. So until now, nothing new under the sun. We've just covered these topics. Then secondly, someone will come in with a question. So let's say that someone asks a question and we want our bot to answer that question. This question is actually going to be what we call it a question, but in data science terms, we call it a prompt. So this question will become a prompt in this case. What we're going to do is we're going to vectorize this question or this prompt. And we're going to do the similarity search that I just explained to see which documents are, or which embedded documents rather, are closely linked to this embedded vector. So you can see that, for example, here our question was the orange dot, and we have a couple of documents that can be closely linked. So those will probably be the ones that contain the answer to our question. What we do then is the vector database will spit out those documents, and we will use the information of those documents and actually add them to our prompt. So how your prompt or your question will look like at that time is, for example, answer this question, or question will be like blah, 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 and then you will add the documents to that question. So for example, answer this question with your question based on this information, and then the information will be given. Then we're going to feed that entire prompt into an LLM, and the LLM will give us an answer basically and talk to us as if it was a human being.
So in essence, if I summarize it, and you might be going to that, the first part doesn't actually use an LLM at all. It's only using vector databases embeddings.
Yes, correct.
Only the last step, we use the language model to kind of summarize then the 10 best documents or the 20 best documents and make an answer that is relevant for the end user.
I'm once again glad that you asked that question, because it's also, if you see it like this, it's not rocket science. Remember when ChatGPT came out, everyone said like, okay, tomorrow AI is going to take over the world, because suddenly there's an algorithm that can talk like a human. But you can see here that actually it's only the last step that is going to do that talking. And what it's going to do, it's going to answer a question based on information that is given, but that information is just being provided by something that we built with indeed our indexers, with our vector database, and so on and so forth. So it's basically just some math and some distance calculation. We feed the results to an LLM, and then it seems like the magic happens, but actually a lot more happens under the belt or under the hood.
And so I understood that there's some limits on tokens, number of words that we can feed into an LLM. Does that mean that we feed the full document or the full document into the LLM, or how does that work?
Good question again. So what happens actually, it's a big issue, so to speak, that you cannot just put entire documents in it. So one thing we will do is we will basically chop the document into different smaller documents, which are then chunks, and those we're going to embed individually. What will happen then, so instead of one big document in your vector database, we will have the different chunks in there. And the vector database will say, okay, I think this particular chunk or these particular chunks contain answers to your question, and it will output those. And not, for example, if you have a PDF of 500 pages, it will not say, okay, these are the 500 pages, LLM, do your thing, and find the answer. So we will break it down, and the small chunks will get into the LLM.
Great, thanks.
Okay, so we say now, like, okay, the LLM is going to do the magic, and the LLM is going to solve the thing. But of course, we want to somehow understand what is happening there, because we explained everything very thoroughly, and then we say, and now the LLM is doing its thing, and you get your answer. But of course, another question is, how does the LLM do its thing to get your answer? And the easiest way, or in my opinion, the easiest way to explain this is to compare creating your answer as building a house. For example, because when you are going to build a house, you will typically need multiple contractors, right? You're building your house. So what do you need? You need, for example, a mason to lay the bricks. You need a carpenter for your bathroom and your kitchen. You need a painter to paint the whole job. And you will probably need a plumber for some tubes as well. So basically, each contractor in the building process of your house has a specialty towards the end result, which is the house that you want. And it's very similar in LLMs. But in LLMs, we of course don't call them contractors, but we call them chunks. Yeah, that was indeed the chunks from the data. Sorry. So we don't call them contractors, but we call them agents, right? So you might have an agent, for example, who is specialized in searching the web. You might have an agent who is specialized in mathematics. You might have an agent who is specialized in talking to a SQL database, and another agent who is specialized in summarizing data. So basically, you can create all of these agents, and the idea is to basically talk to the right agent at the right time to get your goal, which is the answer to your question. Obviously, when we talk about contractors, each and every contractor has his or her own toolkit, and the same thing applies to our agents. So every agent has a certain set of tools they work with, and these are typically the functions. For example, you have generic functions like searching on the web or doing mathematics, but you also can use other agents for yourself. Or you can even use chains, but chains we're going to get into in the next slide. And if you use multiple tools at the same time for a specific goal, you can talk about a toolkit. So you can see how it's very similar to the contractors of house builders. Okay, so what we have now is we have our agents and we have our tools. But once again, very similar to building the house, we want to do the stuff in the correct order. We don't want, for example, a mason to come in. Oh no, sorry, I'm already ahead of schedule. So you need multiple contractors, and you need to basically chain them together, because you're not going to use one contractor to build your entire house. You typically need multiple of them and use them in succession. And the same happens actually with these LLMs. So you're typically not just going to use one agent, but you're going to use multiple agents in succession to get the job done. For example, let's say that you need to retrieve data from the web. You need to summarize that data, and based on that summary, you need to generate an answer for your question. What you're going to do is you're going to create an agent for each of those tasks. So one agent to retrieve data, one agent to summarize the thing, and one agent to answer a certain question. And you're going to talk to those agents in succession and feed the output of one agent as an input to the other agent to get your work done and get to the final result. So, and the thing of doing this, like talking to different agents, is a concept which we call chaining, because you're going to chain your agents obviously together after each other. But then, and that's the thing that I already thought I jumped to earlier, then it's still a problem, because you want to be sure that the agents are being talked to in the correct order. Let's say, for example, that you have a mason, an electrician, and a carpenter. Obviously, you don't want or someone to plaster your house. You don't want that your house has been plastered, and then the next day the electrician comes in and breaks out every wall in your house to put in the cables, right? So you need something to coordinate the building of your house, which would be a site manager, for example. And how we do that in LLMs is by means of prompting. Our prompts are going to coordinate our LLMs on which tasks to do first and to which agents to talk first, and so on and so forth. So rather than, for example, just asking, give me info about the newest OpenAI model, you could ask something like, search on the internet for the newest OpenAI model and check whether element61 has already written an insight about it, right? So now with this prompt, the LLM is going to know, okay, first I need to search on the internet, and then I need to look up something on SharePoint, for example, to check whether there are insights about this. Of course, yeah, you might be thinking yourself like, okay, but do we have to design those prompts ourselves, and do we have to think about all of these steps, like search this on the internet and calculate this and that and so on and so forth? And the answer is obviously no. For that, a shortcut there is using prompt templates. So at element61, we have certain prompt templates which help us and help the LLM to know for which kinds of tasks, which kinds of for which kinds of questions, which tasks needs to be done to provide an answer to your question. So you don't have to bother about this yourself. And then you can also even chain your prompts, but this is a bit out of scope for this session, but you can even chain your prompts for even more advanced reasoning. Okay. I promise this is the last very technical slide, and then we will jump into some demos of how it all works. But let's say, once again, we go back to the comparison of building our house. Let's say you have one house built, and you're very happy of the contractors you worked with, so you basically want to reuse them. What you're going to do basically is you're going to set up an ecosystem around your contractors that you like to work with. Well, we are going to do exactly the same with our LLM. We are going to use a certain framework, in this case it's LangChain, which allows us to reuse the components that we created for future projects or for future deployments of our chatbot in this case. So what is LangChain? LangChain is a framework that allows to create LLM applications by providing a modular abstraction for your necessary components. Another nice benefit of LangChain is that it easily integrates with Amazon, Google, and Microsoft. So it's quite easy to implement it across different cloud providers. So in short, it basically provides developers with the tools they need to create generative AI solutions. All right, so this was it for the very technical part. Now we're going to jump into a demo and show you guys how it looks like. But before we jump into the demo, there's one final small thing I need to talk to you guys about, and that's the thing we forgot up until now, and that's how users are going to use it, right? So what are we going to use as a front end to show our users or to let our users ask questions about their data? So two options are available, let's say, or two options. We worked out two options, which is one is an integration in Teams, which is a very easy setup. If you're already a Teams user, of course, it integrates very well with the Microsoft ecosystem, and the chatbot is right there at your fingertips because you're probably already using Teams. A second one would be through Streamlit, which is a web-based application where you can simply navigate to a link, ask your question about your data, and get the answer right away. Both of them, so both the Teams and the Streamlit application, are really easy to set up. For the demo purpose, I'm going to show you guys the Streamlit application, but keep in mind that the Teams application is very similar. I actually have the demo split out in three smaller demos. The first one is basically your chatbot, but instead of going to like ChatGPT online and asking questions and pasting sensitive data into ChatGPT and so on and so forth with all of the risks that come along with that, you can have your own safe, if you will, ChatGPT, where you only ask questions, or you can still do the copy pasting, which is not recommended, but you can still ask questions as if you were talking to ChatGPT, but everything is confined in your own tenant, which is way safer than asking it to ChatGPT. So let's say that we just had a sales meeting, and we want to write an email to thank our potential customer about the first sales meeting that we had. So we can ask ChatGPT like, hey, can you write an email for that? And ChatGPT, after some thinking, will say, okay, here is an email that you can write. But let's say that the email isn't perfect yet, and I'm going to pause the video for a second. Let's say that the video isn't perfect yet because ChatGPT says, or your internal ChatGPT says thank you for seeing me earlier today, but you actually saw the client earlier this week. And also you want to add some extra information to the email. What you could do is you could say, okay, I'm quite happy with this email, but adapt it so that it talks about earlier this week, and also make sure that you show that you're glad that the counterparty has accepted to have a kickoff meeting in the future. ChatGPT will say, okay, fine, I adapt this email for you. It's now earlier this week, and it also added that you're happy that the kickoff meeting has been approved. However, you're looking at this email and you're like, okay, this GPT is a bit too excited and it's not really professional. It's not really my style of writing. I wouldn't never write, I'm thrilled, and so on and so forth. So you could ask like, okay, can you rewrite this email and make it a bit more formal, a bit less exaggerated? And GPT once again will do that for you. So you can see here that instead of I'm thrilled, it will say I'm pleased to hear, and those kind of things. I was pleased to learn, and I'm looking forward to, instead of being a bit overexcited, right? So that's basically the internal GPT. So it's going to do exactly the same as ChatGPT, but it's on your own tenant, and it's not going to be like your, let's say, your colleagues copy pasting questions and stuff, or data and stuff into ChatGPT and giving it to OpenAI. This will be way more confined in that sense. All right. Then we have the big topic of today is talking about your own documents. So let's say that you want to ask a question about something that is on your SharePoint. For example, an employee at element61 might ask, okay, what type of car does a junior at element61 typically drive? What is then going to happen is the model is going to provide you with an answer, but also with the document, and I'm sorry if this is small to read, also going to provide you with the document where it found the answer, so you can actually fact check that it's actually correct what the bot has answered you. Let's say that you now ask like, okay, is it also possible to have an electrical car or a hybrid car? Once again, it will give you the answer. In this case, we can have a hybrid car. By the way, it was an Audi A3 on the previous question. On this question, indeed, we can have a hybrid car. And element61 also provides an option to help you install your facilities at home, like your charging facilities. So once again, you can see that here you could see it in the answer of the bot, and you can check it once again in the source. Let's say that you're a bit ambitious and you want to drive a Q8 e-tron from Audi, and you ask it to ChatGPT like, okay, to GPT like, can I drive this car? Then it will, well, basically in this case, it will not say yes, you can drive it, which would be obviously a mistake, but it can say something like, I'm not sure, or there are some EVs that you can drive, but please check in these sources to make sure that you can drive this particular car. All right, and then the last component is searching the internet. Because obviously you also might want to be able to search things on the internet in a very human-like interaction way. So let's say that you're interested in NVIDIA, and for those interested, that's the company who tripled in stock this year by their graphics cards and generative AI. So you could ask like, okay, what is NVIDIA? And it will tell you, okay, it's a company that makes graphics cards. And then another question might be, okay, why? And I'm going to pause a bit because it goes a bit faster than I can speak. Why is NVIDIA related to generative AI? And it will tell you like, okay, those GPUs from NVIDIA are being used to train those generative AI models on. And by the way, NVIDIA also created an NLP model themselves. Oh, it's not an NLP model, I'm sorry, but they also generated a generative model themselves, which is a style GAN and a GAU GAN, I'm sorry. So once again, if you want to know stuff that is on the internet, in this case about NVIDIA, you can quickly ask it and get your answers ready. All right. So now we created basically a very simple, let's say rudimentary bot that is able to pick up your data and talk about it. But obviously, as life goes, nothing is perfect, and there are always some issues to solve and some improvements to make. So one question probably a lot of you guys are having right now is, okay, there are these LLMs which other companies are apparently training. Could we do something like that ourselves, right? Could we, or is it opportune for us to train something like that as well? So first of all, what is retraining? That's basically starting from scratch and training your LLM yourself completely, which is a very complex task to do and requires a lot of compute. So what is the process? Your model starts with random parameters. You feed data to it for training, and the parameters will be adjusted. And so the model learns to generate the desired outputs like text or images. So first of all, we have some notes here. The point is, these models are very, very expensive, both in cost and in time to train. And in, let's say, 99.99% of the cases, it's not even needed to do that. We already talked about Hugging Face, where a lot of open source models are for disposal. And I would say in even more than 99.99% of the cases, those models will do the job and will most likely be free as well for use. So there's no need to spend the cash and the time to do it yourself. By the way, retraining, we would compare it to building a new house from scratch, which is also a huge effort to do. Another thing you can think about is, okay, maybe we want to fine tune it. So what you compare that to, instead of like building a new house, you could say, okay, we're going to keep the foundations of the house, and we're just going to renovate some things, and we're going to make sure that the house is good for us, right? One thing about that is that it's also still a lot of work to do, first of all. And secondly, it's also probably not even needed, because it's also still a high cost, a high time that you're working on it. But then thirdly, also like in Belgium, for example, for GPT, there's currently no use case yet where Microsoft had to allow a company, for example, to do fine tuning on the model. Typically, the model as is was already fine enough for the use cases to be done with. And then thirdly, we also have the prompt engineering. So if you would compare training or retraining with building a new house and the fine-tuning with renovating a house, prompt engineering could be compared to, for example, having a paint job on your house. So basically what it is, it's way less effort, and typically your house will look as new with a good paint job and with some very small fixes, which can be done with the prompt engineering. So what is prompt engineering in a nutshell? Is basically providing additional information to the prompt so that you can guide the model into creating a good response. So the model will stay exactly the same, but the output is enhanced a bit by better prompts. So basically, what's the process there? You use the exact same model, but you input some prompts with specific instructions and context, and those instructions and context will be used by the model to adequately answer your question. So what are the benefits there? The benefits are that the context help your model with creating the outputs, and it's also easy to, for example, control the tone, the style, and generating context with certain constraints. One benefit that is actually not on the slide is that it's of course the cheapest and the most efficient one in terms of time to put your LLM into something that is right for the needs of your company. So example usages there are, for example, instructing a chatbot to adopt a formal tone and instructing an image generator to create an image in a certain style. All right. So I sped through that a bit faster than I wanted to, just to keep the time a bit in the back of our mind. But keep in mind that prompt engineering, what you see from prompt engineering, is most likely only the tip of the iceberg of what is actually being done in prompt engineering. And to give you a bit of a flavor of what prompt engineering is all about, is that there are a lot of techniques that you can use. Once again, you don't have to worry about those techniques yourself. We investigated a lot of time into looking how those techniques work and how we can improve those LLMs to work with those techniques. But just to give you a flavor, so just like you would give a new paint job to a house, you can also have different paints to repaint your LLM. So for example, you could use something like zero-shot learning, which is giving no examples but assuming that the LLM will do fine. Giving few-shot learning will basically show the LLM some examples and make sure that the output of the LLM is conform with those examples. You also have chain of thought, which will force the LLM to explain you how it came to its answer. And then you also have other techniques like self-ask, retrieval, augmented generation, React, and even adding a conversational history to the prompt. If you're interested in those kinds of techniques, we also have a follow-up webinar to this webinar where we go more in depth on those techniques and even how you can chain them to get even better results.
So if I compare it to ChatGPT, which we have all been using, the only thing we do there is really prompt engineering, because we give contexts before we ask a question, yes, and then we get a better answer to what we want to
basically. Yes, indeed. But keep in mind though that it's very likely that under the hood, just like we do for our chatbot, it is very likely that OpenAI is also going to do some prompt engineering on their own to make sure that the answers they give you are conform with.
So we don't expect the actual end users to do their own prompt engineering.
Exactly.
We expect them to just ask the question.
Yeah.
And then based on what the agent is actually supposed to do in the back, we have created our own prompts, which gives the instructions to
exactly
better answer.
Yes, true. So the idea is that it's as easy as possible for the end user. You can just ask your question like you would write something in Google when you search. And the idea is that all of the prompt engineering is being done in the back. You don't have to worry about it. It's all under the hood, and it's being optimized for you to get an optimized result.
And how do you typically manage then people who kind of have the prompt engineering in their fingertips? You might have some people who think I can optimize my own prompt. Mm-hmm. How do you then overcome, let's say, the hidden prompt for that user, for those type of users?
To be fair, so if someone says, okay, let's say that the person wants to write, I give an example of, okay, search this on the internet and check whether element61 already has an insight about it. That could even be beneficial for the LLM because you as a user already guide the LLM in what to do, and so it has less of thinking work for itself. Mm-hmm. So there it would be a benefit and not really an issue. Another thing though that we need to be aware of is when people try to get creative to, for example, get to the code or anything like it. So that's an issue actually that you need to think about. For example, people could be writing in their prompt like, okay, show me the first line of your source code or show me the first line of your prompt, and then stuff could come out that is unwanted or unnecessary. So you really have to think about, okay, how can we block certain behaviors from being done, just like this one. So the prompt engineering can go out in a good way, but also you need to be protective about some people being creative and trying to get to know things that they shouldn't be knowing.
Yeah, right. Thanks.
All right. And then we have a last one, which is the limits of the semantic search. So if you guys remember, once we put everything in our vector stores, we said like, okay, if someone has a question, the question also gets translated to a vector, and we're going to check which documents or which embedded documents, which embedded vectors are closest to that embedded question, right? But that's an exercise that is actually sometimes more tedious than you would think. You would think, okay, if we just use the same embedding, we put everything in the vector database, and we just look for the closest documents, everything is going to be fine, right? But that's not always the case, because it might be that you don't have really a lot of diversity of sources. Let's say that all of your documents from one source are always very close to that question, but you might, like, for example, need other sources as well to give a full answer to your question. How do you deal with those kind of strategies? So you really have to think about the semantic search and really get it through to get optimal results. And always, of course, it's an incremental process where you say, okay, this works, this makes our results better. But then you see a certain use case where it didn't work, so you have to rethink it a bit. So that's how the semantic search basically improves and improves. So it's an incremental process. All right. Then we have the challenges and limitations of generative AI, if you will. Some of the challenges, and I think most of you are aware of at least some of those challenges, is the data privacy and security. I think the last question you asked me, Peter, goes right into that security kind of thing, where if people are like adept at creating their own prompts and they try to get information that it should actually not be leaked, how do we deal with that? But also in terms of our data itself, we want to make sure that it's on our own tenant, and we want to make sure that we share the least possible amount of data with OpenAI and Microsoft. So how do we do those things? How do we go about it? That's a very big challenge. Another challenge is the interpretability. It's for a reason that I compared those LLMs with building a house, because they are rather complex, and it is rather complex to see how they come to their answers, but somehow explaining how they came to their answers might be a good indication for a user to say like, okay, I tend to trust this answer more because the LLM told me these and these were the steps that it used. Thirdly is also, of course, the legacy systems that might already be at your company. Let's say that you already have a chatbot, or you want to use generative AI for other things like fraud detection, for which you already have a model. How do you cope with that? Do you integrate your current models and your current systems with the AI or the generative AI solution, or do you fully replace them? How do you go about those questions? Another one is reshaping some of the workforce, and of course also a focus on the rollout and the adaptation. So yeah, obviously if you start from, if you say tomorrow we want to have a bot to chat with our data, of course the people in your company need to be aware of that and need to be aware of how to use it and need to be proficient on using it, because if you forget about that step, yeah, then a lot of extra value can get lost. And last but not least, keeping tabs, of course, on the legal concerns and the algorithmic biases that might creep into those kinds of models. All right. So for the limitations, of course, it's garbage in, garbage out. If you have bad data, it will be very hard to get the right answers from your data. And then in terms of your answers, of course, these are non-binary, which means that answers are based on information, And just like if you would go to a certain person to ask a question about a certain topic, that person might have a lot of experience with that topic or less experience with that topic. How we can translate it is the generative AI model can have seen a lot of data about that topic, or it can just have little information of that topic. So in the case that it has little information about the topic, just like you would do with asking questions to people, you will double check, or you will fact check, or you will check someone else who has more experience. The same you need to do with your AI system. So don't blindly trust every answer that comes out of it. Always be, like we say in Dutch, een goede huisvader, double check the answer and make sure that it's actually correct what is being provided.
I kind of like the if you go back one slide, the garbage in, garbage out is something that is a statement that we throw around quite often in the typical BI projects and the typical machine learning projects. I think it's an interesting statement to make here as well, because what we have noticed is that a lot of organizations have a huge SharePoint or a huge knowledge base, and then they dump everything into the vector database, and then they start asking questions. But of course, you need to manage that information and that data, because the model, in a way, is not super smart to understand that you have 5 documents which have contradicting information. Which one is then correct? It's a difficult one typically, and I think there as well, managing your own proper knowledge base will be crucial if you want to get good results out of the model, right?
Exactly. Yeah. Data quality, like in every machine learning, AI, deep learning, generative AI model will always come back. The data quality that you feed to a certain system. Yeah, garbage in, garbage out, exactly. The quality that you feed to a certain system will also define the quality of the output of that system.
Yeah.
All right. So now we came to the final part of the presentation, your future with generative AI. So there's a big question that comes around, and that's the question of, okay, will AI replace us, right? It's a question that you read everywhere. If you open up a newspaper, if you open up a book about AI, and they all talk about it, both podcasts talk about it, and so on. And the general rhetoric there is that AI will not replace you, but the person using AI probably will, because having AI as a toolkit will effectively enhance your productivity. And so the rhetoric about generative AI here is that your train, or some trains have already left the station, and our train is, or we still have some trains, let's say, that you can hop on, but we will also leave with our last trains one day, and then it will be hard to catch up. So very similar to years ago, like 30 years ago, where people were asking, okay, are computers and telephones going to make us more productive? And the same question now is not only about generative AI, but AI in general. Is it going to make us more productive? And the general answer there is yes. So yeah, don't stay behind. Don't be those people who need to buy a last minute ticket to the train because tickets might be sold out, or other trains might be way ahead of you and already at the destination. Make sure that you buy your ticket ahead of time, that you are on the train, and okay, it will be a bumpy ride. We will need to figure out things, and sometimes the train will stand still, but in essence, we are on the train and we are on the track to the right destination, which is the most important thing, and we can learn together on the journey. So as a last message we have for you guys is let's build generative AI together. To be sure, like the demo that we showed you guys on Streamlit, but also the demo or the solution that we have for Teams are 2 solutions that we can build and or deploy in a matter of 2 weeks at your place. So it's just there ready to go. The train, as I said, is already sitting there. You can just hop on and take the ride. So if you are down for that, and if you are willing to take the leap, then we are there for you as a partner to work it out with you and to see together how this generative AI can work for your company. I don't know if you want to add anything to that.
No, I just added. Let me just reshare. Sorry, and then share again. Normally, you should see my screen again. So indeed, as Joran has mentioned, the architecture and putting it all together, as you see here on the slide that has been shared by Joran, it is something that is today, we have all the components ready, and we have everything ready to deploy this at your environments, making sure that everything that we have explained here is up and running. So you do not need to reinvent the wheel. It is there, and so we can deploy it in a fast fashion. And then it's really up to you, together with us or internally, to further optimize and enhance the solution that you have built. And that is where you should spend time on, is making sure it gets better for your context. My viewpoint would be, do not spend time in figuring it out all yourself, because that's the work that we all have already been doing. And this is what you see here on the screen. Maybe an interesting remark on this, because we haven't actually touched upon actual tools, or maybe slightly, but actual tools and actual solutions, for example, in Azure space. Within 2 weeks, we have another webinar which has a deep dive on each of the components. So if you're interested in that, we invite you to that webinar, so you can walk with us through every component. The alternatives there might be, because for every part or every block that you see on the screen here, there are multiple alternatives. So that's a deep dive that we will be doing in 2 weeks' time. There were some questions being asked, and I added them into the slide deck. So first question, and I try to answer myself, so maybe you can comment on it. So how accurate are document extractors? How can they cope with image-based data, for example, scanned PDFs? I think the answer I gave, so maybe you can comment then, is there are, of course, different types of documents, as we have seen. There are also different types of extractors and or document loaders. So for each document we have, there's a specific loader which can handle those documents. The easy ones are, of course, the PDFs, the Words, the Excel, because those are kind of standard formats. If we look into images, scanned PDFs, for example, it becomes a little bit more difficult. But there are, for example, in cognitive search, which is a tool that we use quite often, you have the concept of skill sets, where OCR, for example, to recognize scanned PDFs, it's a skill set that we can enable. And so we just feed the scanned PDF, and then we translate it into a digital format, and then we can embed it. Similarly, for images, we can kind of have an image analysis skill, which says what is now on this picture or what is now on this graph, translated into text and then into an embedding.
Yeah, exactly.
I think that's how it.
So yeah, it's indeed the concept of the document loaders, and you have different document loaders for different use cases, and these also obviously get better and better. So yeah, to answer that question, it's perfectly possible.
And there as well, an interesting one I added here, for example, PII detection. You have those skill sets which can further enhance your metadata. And so we might know this chunk of text contains very sensitive data, so we can tag it with sensitive data, and then in the prompt later on we can say, do not include sensitive data in your answer. And so by combining then the skill set of PII detection, so personally identifiable information, and a good prompt engineering, you can limit kind of giving information that we do not want to share. And then another question on the chunking part. So will chunking run the risk of misrepresenting context compared to the original document? So I think there you mentioned you have a full document. We split it up into smaller chunks, smaller pieces. How do we make sure that the context of the full document is still there, knowing that the chunk is only part of the document?
That's also a very good question. I'm glad that it comes up, because it's something that I didn't have time to mention. There's actually two things there. First of all, there's the trade-off between making smaller chunks to make sure that you don't get to the token limit of your model, because every model has a certain limit of tokens, and tokens you can, for now see as like the number of words, if you will. It's very comparable, but not exactly the same. Yeah, exactly. To basically feed into that model. And if your chunks are really big, then you're going to fill up those tokens easier. So if you have very big documents that you don't chunk in very small chunks, then you're going to run into issues there. While on the other side, if you would say let's say every sentence of my document is a chunk, then you of course lose all of the context. So there's a balancing act that you need to do between, okay, how fast am I filling up my chunks versus how many documents do I want to get in. But there's also another concept, which is the second part of the story, which allows you to do some kind of overlap. So you can say, okay, I'm going to chunk per page, for example, but I'm going to use the last sentence or the last two sentences of my previous page as like an overlap between my documents, so that I keep somehow a bit of context through my documents.
Maybe interesting to add here indeed. So chunking, it's kind of a strategy on itself. So how can we optimize the chunking? We can make use of the NLP techniques that have been there for many, many years in understanding what pieces of text are actually belonging together, what pieces of text have an overlap or contain context for this chunk.
Yeah.
So we can make use of those I will call it now old NLP techniques to give you more content-aware chunking and to have a dynamic chunking rather than just saying per 500 or 1,000 tokens, which is a rudimentary way of chunking, right?
It also, by the way, refers very much to what we said earlier in the slides with the vector search, where you are going to, or semantic search, which is actually the same, where you're going to search for relevant documents. Like chunking and vector search are two issues that are very related to each other.
Then there are two questions asked. I didn't include them in the slides. That was a little bit too difficult. On the hallucination part, right? So LLMs are typically known to hallucinate, where some data from the internet is being used, some data from some information from your own data, and then an answer is being generated, which at first sight looks very good, but if you then fact check, there might be some incorrect information in there. How do we cope with that? Are there techniques to kind of mitigate that?
Yeah, it's a good question. I think the answer is two or threefold even. One part of the answer there is making sure that your data to begin with is of good quality. As you already said, if you have 5 documents with 3 documents saying one thing and 2 other documents that might be deprecated saying something different, then you might have an issue for your LLM. That's the one part. Then the second part, if it's not your data, it can of course be your LLM itself. So there, you continuously have to check, okay, what are problem areas that are, for example, reported by clients and so on or so forth, or things that we encounter ourselves where we see like, okay, this information was actually present in the data set, but for some reason we don't see it in the answers, or the other way around. We see that we ask a question about something that is not in the data set, but the model is creating an answer for it. And then we need to check, okay, why could it be? There are obviously some reasons, but hallucinations will always be there to a certain degree. You can minimize them, but not eradicate them. So that's also a balancing act of keeping improving.
Yeah.
And then the third one would be what we already covered is make sure that you always fact check your answers. So it's not the goal that a chatbot will replace your search. It will enhance your search and make it faster by saying, okay, this is the answer with a very high likelihood. And by the way, here is where you can fact check it.
Yeah.
But never be the lazy person who doesn't click on the source to quickly verify. Okay, this is indeed the answer that I need.
I think Lewis mentioned it in the chat as well. You can also set the parameters of your model. For example, it's the temperature parameter, which you might have heard about. So 0 is factual, 1 is very creative. So you can play, of course, with that as well.
Exactly.
And then a last question, and then we will close up, is everything related around pricing. It's something that we will discuss in the next session as well in more detail. As always, Microsoft is kind of applying a price per volume or number of tokens that you apply. There might be a risk where you overuse your tokens and that you have a high cost. In essence, I think it's very simple. You can limit the number of tokens that users can ask by creating or inputting this in your front end, right? If you tweet, you have, I don't know how many tokens you have today, 140 or something, or characters, or sorry, it's X, by the way. But you can limit in your front end where you say, look, your questions can only be, let's say, 500 words long. And so it's just an easy way to limit the question. Similarly, on the prompt that you, or the question or the answer that you get back, you can also prompt and saying, by the way, limit my answer to 3 paragraphs, for example, so that you don't have too long of answers and questions being constantly fed to the models. And so you kind of force a limit on your tokens, which is resolving this.
Yeah.
But it's something that we will discuss in the next session, which is then the final slide of today.
Yeah.
Today was more an introduction in what generative AI is and what how you can chat on your own data, giving you some more conceptual information around vector databases, embeddings, the NLP, the LLMs. Next week, we will dive deeper into the actual, 2 weeks time, the 27th of September, on the actual tools that you use in Azure, how we can activate them, what are the pros and cons, what is the price of each component, so that you have a better idea on that end. So we invite you all to join in that session. It will be similar format, so an online webinar where we go into depth of each of the concepts we just tackled. And we hope to give you more insights in that. If you have any questions with regards to the session of today, feel free to reach out. You will get the slides, so you will be able to go over them yourself. And we're more than happy to assist you, to give you inspiration on what are the possibilities in your environment. And as mentioned, do not spend time in figuring it out yourself. We are here to help. We have spent already a lot of time in figuring it out. So deploying what you have seen is something that we can do in a matter of 2 weeks. So if you're interested, feel free to reach out. So thank you, Joran, for the session. It was very insightful. Looking forward to seeing you within 2 weeks in the next webinar. And if there are any questions, feel free to reach out to us directly. And enjoy the rest of the day.
All right. Also